Hi, my name is Bilal, and today I'm going to be talking about Gay-Lussac's law. So first, let's take a look at the origins of Gay-Lussac's law. Joseph Louis Gay-Lussac was a French chemist who discovered one of the fundamental laws of gases, which is now known as Gay-Lussac's law, although he shares the credit with Guillaume Anton. Joseph Louis proposed this law in the early 19th century and conducted his first major research in the winter of 1801 and 1802 at only the age of 24. Gay-Lussac's law basically states that pressure and temperature are directly proportional, like you could see on the graph. As temperature goes up, so does pressure. P and T are proportional. So that can be mathematically written as P equals KT. P being pressure, T being temperature in Kelvin, and K being the proportionality constant. This can also be arranged as P over T equals K. Some examples of Gay-Lussac's law that we see in our day-to-day lives are tires, pressure cookers, aerosol cans, and propane tanks. What all four of these have in common is that they can all explode if they're heated up enough. If you think about it, if you heat something up, the particles inside move faster, meaning that they hit the wall of the container more often per second, making the pressure increase. Same way, if you slow something down, the particles inside will move slower, making the pressure decrease. Usually, Gay-Lussac's law is used to compare two situations, a before and after, often a temperature increase or decrease. For that, we'll use the formula P1 over T1 equals K for the before, and P2 over T2 equals K for the after. This can be more simply written out as P1 over T1 equals P2 over T2. For our first example, we're going to use the example of a tire. A tire has a pressure of 35 psi at a temperature of 20 degrees Celsius. What will the pressure be if you increase the temperature to 30 degrees Celsius? First, we have to remember to convert the temperature to Kelvin. We do that by adding 273.15 to however many degrees Celsius. We come up with T1 equaling 293.15 Kelvin and T2 equaling 303.15 Kelvin. Then we substitute what we already know into the formula we got earlier. P1 over T1 equals P2 over T2. We end up with 35 psi over 293.15 Kelvin equaling P2 over 303.15 Kelvin. Next, we have to solve for P2 by multiplying both sides by 303.15 Kelvin. So you can see I did that in the first equation. Then I come up with 35 psi times 303.15 Kelvin over 293.15 Kelvin. And the answer ends up being 36 psi. So you could see that the pressure in the tire only increased by 1 psi. For this next question, we're solving to find the temperature, not the pressure. So our question is, in a fixed container at 20 degrees Celsius, a gas exerts 0.9 atmospheres of pressure. At what temperature in Celsius will it exert 0.75 atmospheres of pressure? So first, once again, we have to convert the temperature to Kelvin. We do that by adding 273.15 to however many degrees Celsius. That equals 293.15 Kelvin. Then we substitute what we already know into the formula. P1 over T1 equals P2 over T2. Our equation becomes 0.9 atmospheres of pressure over 293.15 Kelvin equals 0.75 atmospheres of pressure over T2. So finally, to solve our question, we use the equation from our last slide to solve for T2. We do that by multiplying 293.15 Kelvin by 0.75 atmospheres of pressure over 0.9 atmospheres of pressure. The answer is 244.29. We have to remember to convert Kelvin back to degrees Celsius because that's what the question asks. We do that by subtracting 273.15. Our answer ends up being negative 28.86. So the answer to the question would be to get 0.75 atmospheres of pressure, the temperature needs to be negative 28.86 degrees Celsius.